start the stream and start recording. Copy the stream. Okay.
I wrote a really nice cover letter and actually leadership for like half a minute, which was fucking awesome. You would be like, go fuck yourself, and like I can handle that, not just like.
All right, let's get started with class. So Saturday was introduction to constructors, right? How are we feeling about that? Fist of 5. How are we feeling about constructors after Saturday? Got some numbers all over the board. Okay. So if constructors are still not making a lot of sense, just try to think about them this way. They're just functions. It's literally all they are. Technically, any function that doesn't return anything can be turned into a constructor by adding that new keyword in front of it when you call it, right? Because when you call new, it knows to return a weird object thing that it kind of generates from the constructor, right? So I can have any function. That's it. It could be just that. Make something. I put new in front of it. Magically, it's a constructor. And I can console log it if I spell it properly. So if I just check out node and what node gives me, it gives me that object, right? And the reason why we know it's that object is because in front of the object curly braces it says the name of the object I just created. So I called this constructor make something, and when I console log it, I see make something and then whatever properties it has. Well, I didn't give it any properties, right? There's nothing fancy there. It's just an empty function. That's all a constructor is. It's just a function. Now, if I start returning stuff, it gets more complicated. But the heart of it is what it is. So say I want to have some sort of a property on that constructor, right? Well, let's just say I want to give it a name. If I run that again, now it's going to show my name. There's an important thing, though, about these constructors that make them pretty powerful used in the right context. And that is that make something that it says right there, that type name, right? It tells you the name of the constructor. Now, this is basically our weak form of typing that we get in JavaScript. And when you learn more about typing and why it's important, is it adds context to why you use something, right? So we could just have a function make something that return an object. That's good. That's all well and good. And I could still have the same object named Carson. But if I can console log it and see it's the make something, well, what if make something is really important in a set of processes in my code? Because I have make something attached to that, and when you console log it and you know what that is, you can kind of deduce some properties about that type, right? So it's not so easy to see that here with this kind of trivial example, right? But say you had a complex application. I'm doing this myself in my own projects. And you have some sort of an object that you want to represent some concept, overarching concept in your application. If you give it a good, well-named constructor and you keep that constructor with every definition of that object, one, you can guarantee certain properties exist to an extent in JavaScript. And two, it adds context to why you're using those values. So they are very important using constructors. Now, one of the things in JavaScript that people say often is, oh, you don't use them a lot, and oh, they're not necessary. They're not necessary, and you don't have to use them a lot, and a lot of people don't use them. They kind of skirt the system because it's faster not to. But just because it's faster and more convenient not to doesn't mean it's necessarily better. So depending on the context of why you would use something is why they can become very important. Now, understanding them is very important for understanding how we're going to use Node and JavaScript in the future, because there are a lot of things that do use constructors, and so understanding their idiosyncrasies and how these weird functions work is really important. So, does anyone have any questions on just basic constructors before we move on to class and we start continuing on? Everyone feeling okay about it? Was that helpful at all to those who weren't feeling as confident? Yeah, a little bit helpful. Okay, it's good. Yeah, so just try to limit your understanding at first to a function. Once you understand it's a function with this new keyword in front of it, that's it. That's a constructor. You're good. You don't really got to worry about much else at first. There are some weird things with them, but we'll get to it.
So if you screw up and you don't, let's say you can't include the function and you get in front of it, will it still run as constructor?
It's a great question.
This will work, right?
The casing means nothing to a constructor. It's just a function. Now, it's often convention to have a constructor function Pascal case, right? Where every word's capitalized. Because it basically is like a way for us to quickly identify that it's a constructor. In JavaScript, at least. Yes. There's no other time you'll use new, just for instantiating an object. And it's like that in a lot of languages, but JavaScript's a little fast and loose with the rules, so it's there for some reason. People could argue that it's not useful to have new, that they could have done this another way. Well, maybe. It confuses some things, but it's there, and we should learn it. Any other questions? Cool. We're going to go ahead and do activity number 5, programmers. To warm up for today in this activity, you're going to create a constructor function called programmer, which can be used to create objects containing information on various programmers. So you're going to have a programmer's name, job title, how old they are, their favorite programming language, and then you're going to add a function to that constructor, to that object, to print that information, and then you're going to call that information and show how it works, right? So it's activity number 5, I'm pretty sure. Yeah. Yes. 5 programmers in the GitLab repo. And we'll spend a few minutes working on that. Spend like 5 minutes and then we'll go over it. Alright, let's go over this one real quick. I know that was quick. We didn't have a lot of time. I don't expect many people to have finished. But we had to create a constructor for a programmer that could take in a name, a title, an age, and their favorite language. Right? It was age. Was the other one? Yes. And we needed to create an object with those properties, and then we needed to have some way to print that information to the console, and then we needed to demonstrate it, right? So we needed 4 properties. Now remember, again, this is a function, so you can pass parameters into it just like you would any other function. Now here's where the difference with a constructor, again, comes into play. When we're using a constructor, we don't want to just assign these to something. We want to assign them to this, because when we use that new keyword, we're instantiating a new object. We want this to change so that that object that comes out has all the properties of this, right? So if we just do this name equals name, this age equals age, this title equals title, and this dot lang equals lang, right? So now our programmer has those properties, and we can test that really quick. Carson, 26, developer, and what's a good language? I'll just do F# for now. And then if we just console.log this new instance and run this, let me clear first. You can see I have my programmer, has my name, age, title, and my language, right? So again, this is where that context comes into play. If I have an application built around, say you have an employee management application built around programmer specifically, and you want to be able to manage programmer and development time, you might have an object in that application called a programmer where you want to keep track of stuff like this, right? And if I console log that object as it's moving through the application because I'm debugging it or something, it's much easier for me as the developer to understand, oh, this is a programmer, this is supposed to do certain things, right? A programmer may be someone who can mark down time on a card. They may be someone who can request time off. I don't know, right? So there's going to be certain attributes associated with that type, that constructor, that allow us to kind of deduce how it should be used, and that's what's powerful about this thing. Also, we can force the user of the programmer function to kind of put in certain properties, right? So we can guarantee that that object, to an extent, has those properties. I say to an extent because in JavaScript, you can kind of do whatever you want, so they don't have to give you those things. But then they're just, kind of being an asshole, so I guess they're not using it right. But anyway, there was a second part to this, and that second part was we need to be able to print information about this programmer. So everything we just put in there, we need to print. There's a couple ways you can do it. There's the prototype method, programmer, where you mutate the prototype like so, right? And we can assign a function to a prototype property of this constructor. Does anyone remember what the prototype is? Did you guys talk about that much? The prototype is like this weird under object that every object has that just controls what it does. It's real weird. It's more complicated than that, but anyway, so if we want to do print the info, we could do something along the lines of name, this dot name, age, this dot age, title, this dot title, right, and then I can actually, right down here, call print info, and you'll see my print info string is part of that object that I created, and I can just call it. It's there. It's nice. There's another way you can do it, though. If you don't like the prototype and it doesn't make sense, you can just append it to this, if you'd like. just like we have the properties on there. Because this is effectively working as the prototype. It's a little different, but it is effectively the prototype, right? So let's just copy this right here. And then this one will be the other print info, and then we can just, again, call the other print info, and we get the other print info.
Now, is that only because you don't want to do console log and write out the whole string a bunch? Is that the only benefit to using them?
Yeah, so in this scenario, that's the benefit. We want to use the constructor. Well, the whole reason why we use these constructors is to save us time.
Well, not the constructor, but the other ways to quote-unquote function flow.
Right. So they kind of go with that constructor. They are part of this object that we're creating, right? And this constructor encapsulates certain information. It has a name, an age, a title, and a language, right, that associates with the programmer. Well, we have other stuff we want to do with that data that we can also associate with the programmer to save us time, so we don't have to do it over and over again. So yes, it's a time-saving mechanism, which is what constructors in general are considered. A time-saving mechanism, a quick function you can make to do some stuff for you. Now you will notice, because my other print info wasn't on the prototype, when I went to call it from VS Code, it actually thinks it's a variable. Now it knows right here in the property description that it's not. But you can see I got the little blue thing, but here, if I type print info, I get the purple box, which is a function. So VS Code, actually, that's interesting, is reading the prototype for function calls. Now if I do something really heinous, I don't know if this will work, because I think you got to get to the prototype from out of. Yeah, see, can't do it that way. So the prototype I can only access from outside of the constructor, because it's like a global thing, the prototype, based off of the function. It's not something you can just access. There are ways you can get to it, and it's real funky, but I don't recommend it. Anyway, these are the two different ways you can add functions to a constructor, right? Any questions on this little example?
So when you're using the money signs like curly brackets in the console log, does that just make it so you don't have to use it like plus everywhere pretty much?
Yeah, this is that's a good question, because I wasn't sure if you guys had seen this yet, so I wanted to do it. This is called string interpolation. Basically, you use tick marks instead of single quotes or double quotes around your string, and whenever you want to inject a variable, as opposed to adding the plus sign to do it over and over again, you can just use a $, curly braces, and put whatever you want, any literal inside of there. So it can be a variable, it can be another object, it can be a string, a number, boolean, doesn't matter. It'll automatically figure out how to print it, and print it for you in the string, like if you're using the pluses. It's a much more convenient way to do it, and it's the recommended way when you have a long string with lots of concatenations, right?
Yeah, let me find I'll find an article on it and put that in Slack so that you guys can use it.
Yeah, if you guys want to, I would recommend you learn the syntax because it's one, more efficient, and two, way easier. So, what? Redo all your homework? I would redo your homework for it, but moving forward, I would do it this way. Any other questions on constructors and stuff? Cool. So, again, like I was saying, Heather kind of segued us to the next point we're going to go over today. And that is that constructors are supposed to be a major time savings, right? Because you can associate all this information with the constructor and with the type. So in JavaScript, constructor and type are kind of synonymous. In more structured languages, we have this idea of types. So in JavaScript, we have strings, booleans, numbers, objects, and arrays, right? But outside of that, we don't really have any concrete types. We don't have something saying, this has to be type programmer, or something is wrong, right? JavaScript doesn't have that because it is dynamically typed, but constructors are kind of like a fast and loose way of doing that, where we can associate a type with a variable. So we're saying that this object is of type programmer, okay? And again, typing, as you'll learn more about it eventually, not much in this class, is extremely powerful for context. We spend probably 80% of our time, at least that's the random statistic I read once, programming, reading other people's code rather than writing it, which is probably pretty accurate unless you're writing a new application and you happen to be the one guy doing it, right? You read a lot of people's code, and type information that's missing from JavaScript is extraordinarily important for understanding how things work, right? Because it adds context. And used properly, it's very, very powerful. More than just the other things you usually get from a type system, like static compile time checking to make sure you didn't mess up. Anyway, constructors kind of give us that. So I would say they add a lot of value in that regard. Do you always need them? No. Sometimes they're not worth it because they are more work. But there are times when they're definitely worth it. So anyway, how do they save us time? Well, we have the luxury of being able to attach functions to our constructors through the prototype or whatever that allow us to basically take all the information associated with the constructor and do something with it over and over. Very repeatable, right? Without having to write the same code over and over again. Why do we use functions? We use the functions for the same reason. We want to share functionality, and we don't want to repeat ourselves. Smart programmers write as few lines of code as they possibly can. Not always true, but it's a very general statement because we're lazy. Smart programmers are also very lazy. They don't want to do this work, so up front, they'll do a little bit of work to kind of make it easy to do it again and again and again, right? And that's what functions and especially constructors allow us to do. So, say we wanted to build these programmer objects quickly and easily without having to do much work. Well, we could add Inquirer, right? And we could ask these questions to our users and be like, you come up with your own developer, right? I don't care about the programmer. I just know that that construct has to exist. But you yourself come up with what that looks like. So, if I can off the npm install and what is your name? Carson. What is your current position? Developer. How old are you? 26. What is your favorite programming language? Let's do F#. And we get that same information that we saw with our programmer, right? In the last example. Now we can just use the convenience of Inquirer and the convenience of the constructor in one to kind of work together. Any questions on what's going on here?
Why isn't type in the
Why isn't the type of these
Yeah.
messages in Inquirer? It probably defaults to text. And so the default value when you don't put something is just the text value, so they left it out. That's a good question. A lot of times, in JavaScript especially, it's a language where, because things are so ill-defined always, it's very sensible to define reasonable defaults for everything you do. So if you expose a third-party interface like this, like Inquirer, say you make a package like that, giving reasonable defaults for all of those things is a very, very good idea. Now, there could be some things that you just can't get away without, right? So if we didn't have a message or we didn't have a name there, we might, as the Inquirer package maintainers, just throw an error and say, you literally can't do this. This is stupid. And no one should ever ship that code, right? Because if they tested it at all, they would have gotten that error, and they would know that Inquirer does not work that way. Otherwise, for something that doesn't necessarily need to be that important, for instance, the type here, we can just assume they're all going to be text then, freeform. Because even though Inquirer has better constructs for things like checkboxes and lists and all that, you could technically freeform every single answer you would ever think of in Inquirer, right? So it's a good, reasonable default. So it's a great question because you're going to see that a lot in JavaScript, especially in a lot of packages you use, where there's lots of reasonable defaults, and you can assume that they're going to be there if the package is well maintained. I don't want to say you should assume and you should try to use them, but if you know they exist, take advantage of them for sure. The only thing it does, though, that was hinted at by Jaime's question, is it makes the code a little more confusing. Because now we have no idea what's actually happening, right? We have to run the code or assume. And those are bad things, because if you have to run the code, well, then you got to have the right environment. You have to build everything. If you're just trying to do a review really quickly, it makes it harder to really review what's happening, right? Or you're making assumptions, and that's not a good thing in programming. So, yeah. Any other questions on this little example? How you can match the constructor with that Inquirer prompt? All right, so I'm going to slack out this code to you with a couple of instructions for you. Let me get to it. I'm getting there. All right, I'm going to slack out 2 versions. There's the one with the prototype, one without. You can choose whatever one you'd like. It doesn't much matter because they effectively do the same thing. So here's the deal. I want you to spend a couple of minutes taking that code file, work with the people next to you, and try to make it execute in a loop. And by that I mean I want you to ask for 4 different programmers. And I don't want to ask for 4 at the same time. I want you to give me one programmer, and then ask me for another programmer, and then another, and then another. And at the very end, print all 4 of them. That's your challenge.
Say again what you want us to do.
What?
Say it again what you want us to do.
You need to take this code.
Okay.
You need to do this 4 times in a row and then print all 4 programmers after I have all 4. So you're going to ask this once, create a programmer, ask it again, create a programmer, ask it again, create a programmer, ask it again, create a programmer, and on the 5th time through, you need to print the programmers and exit the application. Like a loop. Like a for loop. And then save all of them. Go ahead and see if that works.
And this is the same code that's in example 6 that you put it out.
This is the same code in example 6. Yeah, you could just use example 6 if you didn't want to use the one I selected out, which is literally example 6. Yep. 8, 12, whatever. 812X. Or 810 and above. What version is he on?
It's version 0.10.32.
Go install the LTS again. Do you have NVM? Or did you do it manually from the Node.js webpage? Just go to the Node.js webpage and install it again. Version 8 and upgrade. All right. I didn't give you a lot of time to do this, but we're going to go through it. We're going through it together. That's the point of the exercise. Because there's a way to do this that I'm going to imagine no one's going to get, and that's by using recursion. Because using a for loop won't work. If anyone has tried a for loop already, they'll notice that it is a terrible solution for this and does not work. And there's a reason why it doesn't work. Does anyone know off the top of their head why it doesn't work?
The for loop?
The for loop. Why wouldn't it work? Where would you put it? That's a good question. What if I put it around this inquirer prompt?
You need to save all the objects that it's printed to an array and it has to get them up to the array.
But, okay, so say I did that. Would it work? With the for loop? Now you don't know. Okay, well let's go ahead and try that and see what happens. So we'll create an array, right? So intuition says that this is how you would do it, right? At least I would think up front that this is how it would be done. Whether it is or not, we'll find out. Obviously it's not, I'm telling you it's not, but... So we have programmers, we're going to go ahead and push our new programmer, right? And then at the end here, for var p of... So we can use our cool fancy loop, and we can just do p.printinfo. Should work. Should work good, huh? Let's run it. Whoa. That's not very good. So already we've failed because One, we wanted it, first of all, I did it 5 times, so I can't count. That's the first problem. Second of all, we got the what is your name printed 5 times in a row. Why? Because it's asynchronous, exactly. A for loop will not work on the asynchronous code. No way, no how, can't do it. But there's a way you can do it, and that is through recursion. Does anyone know what recursion is? Off the top of their head? Call a function within that function, specifically calling a function within itself, so that you can call it over and over in a row. Now, intuitively, you could probably already see that this means I could create a function that calls this one time, and then calls itself again after I've created the programmer, and then again after I've created the programmer until I get to a certain point, and then it can stop itself, right? So with that in mind, we can keep this programmer's array the way it is, and this for loop's going to change instead. Now recursion is extremely powerful, I'll tell you right now. It is extremely powerful, but especially in the beginning and for even a lot of seasoned developers, it is a very confusing topic. If you get good at it, that's awesome because it is very powerful. And definitely has a very big role, and more so in JavaScript. So let's create a function. Make programmer. Okay. We don't even need that. We'll call it make programmer. And we're going to go ahead and get rid of this for loop because we know that that doesn't work. And I'm going to go, I'm just going to copy the inquirer code. And I'm going to put it in this make programmer. Okay? Now to start our recursion chain, I just type make programmer right there after we push the new programmer. Now this works already. I can tell you this works because when make programmer happens, it's going to start the inquirer prompt, go through all of that, but not until the prompt is done will it eventually call make programmer again, right? Because we have the then function. So it's asynchronous. It's waiting until it's done to call itself again. At that point, well, we want at most 4 programmers, right? So right here, if programmers.length equals 4, then we can go ahead and take our little loop. And leave the function. Right? Once it's at 4, we just want to print them, and then we're good to go. Then we can start the make programmer chain right there at the very end of the script. So, I know I didn't get a chance to show you very much, but let me run through it first. Alright, off to a good start. I'm going to cheat. Okay, great. So I went through 1. We started again. Oops, we're on the next one. This is the 4th one. And there we go. We get A, B, 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 C, 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 D, 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 D. Not very creative programmer names, and as a matter of fact, I wouldn't recommend you hire people with those names, but that might be prejudice. Anyway. Point being, recursion is a way you can solve this problem. Now, why am I telling you about this? Because you're going to deal with asynchronous code a lot, especially with Inquirer and other tools like this that require you to wait on something. Think about Ajax already. We've done a lot of that. Think about Request.js that we've done a lot of. And now Inquirer, all of those things require us to wait. And there will be scenarios where you'll say, I'm going to need to make 5 requests in a row, but the requests are all dependent on each other, right? They require the first request to make the second, and the third, the second to make the third, and so on and so forth, right? There's not an easy way to do that with a loop, at least. There's other ways to do it. There's not really other ways to do it. You pretty much have to use recursion or some sort of weird, grotesque loop-like creature that can kind of get the job done, but will be really confusing, and no one will like you. So I don't recommend that. Recursion's really your answer here when it comes to asynchronous programming. Because it's like a callback system, right? Hey, this is done. Go ahead and do this other one now. It's effectively our answer there. Any questions on this code right here? I'll slack it out in a moment. On what's going on. Cool. So, recursion can be confusing. This scenario I don't think is too bad because make programmer doesn't do a whole lot. But if make programmer had to have information passed through it, it would be a lot harder. Now, say for instance, we wanted to have the count. Say we wanted to have a count, right? Pass through here. If count is 3, pass that there. And then right here, we can console log the current count is going to be count. Now you'll see this one's going to be harder to follow. If you were to just look at it really quick, you'd be like make programmer 0, and then you have to like kind of follow where count's going. Now granted it's only one thing, so it's not too bad. But you can imagine if you start passing a whole bunch of stuff into these functions, and you're incrementing them and changing them with each recursive call, and there's some condition based off of that, it gets hard to follow. Now, current count is up to 1. Current count is up to 2. And I stopped short 1. Any questions on that? Alright. I'm going to get rid of the count because I want to do it off the programmer's length. Let me change this. I'll slack it out, and then we'll talk about your activity you're going to do that is going to take effectively the rest of the class. Alright. Let me slack this out. This is programmer's prompt. Alright, there's a recursive example that you can inspect at your leisure, and then TAs, if you wouldn't mind, if they don't have that one already in GitLab, slacking out the actual official version. I think it's activity 7. Okay, so we're about to start on a pretty complex activity. You're going to work on obviously in groups. The first half is going to take you about an hour. We'll do that, take a break, then we'll finish it up, take about 30 more minutes. And then we'll do a couple last activities just to finish off the day. So this activity, it's called the Team Manager, is going to require, obviously, constructors, probably some recursion, and it's going to require inquirer, right? So over the course of the assignment, you're going to put together a function that uses constructors and user input to create and manage a team of players. Start out by creating a constructor function called player with the following properties. And there's a bunch of properties, or there's a bunch of methods and properties that you have to define. And then you have to create a program that takes in user input and creates unique players, and then eventually a team, and then allows you to interact with them, right? So this is going to be, I think, activity 8. Let me look. Go up here. Yep, Team Manager. So you're going to get started on this. And we're going to spend about an hour with the first set of functionality, and then we're gonna pick up on it after our break and finish it up. So work in groups. This one's gonna take you a while. We'll come around and we'll help you from time to time. If you get stuck, let us know if you get stuck, because you don't want to get stuck at one part for too long. If you're stuck on something for 10 minutes and you have not made any progress, tell someone. Either tell a student that you know is farther along, or tell one of us. That should be your rule of thumb. So go nuts. Slack out 7, the recursive function solution for them, and 8 is what they're working on now.
Did you make the text larger on the screen?
Yeah, because I don't want you to start on the second half anyway. So. Alright, that's what you should be working on before this break, is this chunk. If you get further along, you know where you can find the instructions.
How did you get your jQuery to work without like tagging it? Like when I copied your code, as you were doing it, my jQuery was like,
That wasn't jQuery. That was string interpolation. So it's different. It has dollar signs, but it's not jQuery.
It might be what I was thinking, instead of like a single quote, it's that thing on the top
I
left.
just, one of my things was one, which is kind of like,
Yeah, it's the top left.
Kick marks, not quotes. So we're going to double quote, you need to put the kick.
oh really?
Yeah. You can do as much as you want.
Like that?
No, you can have any quotes. So you have one there. Put one there.
Oh.
Put it in front, and then you use one at the end. And then you use one. Yeah, it's in the couple of
It's not complicated.
no, I know, this is, you just wrap it or something.
I don't know.
I would, so now at the end here, you know, kick mark in the first one, then it's So we have the dollar sign in curly braces around it, or parentheses. Replace those parentheses with curly braces, and keep the dollar sign there. We'll get the
You still have to use slash n if you're doing line interpolation, or does it know like where
You can do /n, or you can actually do a new line.
if you just put it under it, it'll print exactly how it's
Just in between the two ticks, you can do as many lines as you want, as much space. So yeah, just don't close the ticks until you're ready.
You just want to keep on. It'll actually break the line for you.
I'm pretty sure.
Lays on the liquor again. Gotta watch out for those shit tires. Come on.
I got sad.
Oh god, yeah.
Yeah.
Oh man. I'm just looking at you drunk. You don't steal that. That's a curve. Sweet express.
Oh yeah, it's all formatting for future. Should we be using things like inquire and stuff if we think the activity that we're doing raw? Yeah. We could say that raw. gathers, crazy graphics, just gathers. Yeah, add flip screen, 3D flip screen. Like just chances, yeah. It's just always a 1-for-1 trade.
I might have said it in the brain, but I'm pretty sure I said the word like 0, 1, and 2. No, you figured it out. You didn't hire it. Fuck you, boy. Let's do a flat. Very better about that. Just tell me to take it.
Finally, I'll be good at something.
Yeah, man.
Concentrate. That's the V8s, that's the V8s.
Thank you.
Literally said thank you. I told you that. They gave him the default and no devices.
No.
I was hoping at least one person in our cohort would at least got the behavioral portion of the interview. Well, at this point, man, if they could, that was the none of I think they viewed it as the 10th, and if they contact me tomorrow, I'm going to make sure it's just like freaking box with. By the way, I can post it, make sure you guys have the same word.
Okay? You gonna do it? Okay. You stuck on them or are you doing okay?
You're doing okay, you just like.
I did like a PM minute. I got this. Just say enter. Shaky Bender, I know too. It's been a while. I was like, wait. You guys will do it okay?
Woo! Got him. Are you here all night, dude? Are you here all night?
First show's never like the second.
You come here and bitch us if people Dutch roast, think you're some that sort of jokester, and then you just keep going. Or sometimes when you and
I saw
Dutch
you.
roast kids.
I saw you attempt that dad joke earlier tonight.
Which one?
I don't remember.
No, that's not helpful.
But I remember that you did. So I was like,
That's the response I get. Garrett gets a
well, you were teaching. I didn't want to interrupt.
uproarious laughter. I get quite.
You tried. I didn't really
No, it was good quality.
Well, a lot of it's just being a professional ball buster today.
I tried my best.
Yeah, you can go back to my house.
It's ruined your day.
It doesn't ruin the day.
Brew the day, Trebek.
That was beautiful. Blow it up.
Saturday morning exercise on Mondays.
He's around the room.
Hey, you just steps in.
I think it's long enough for me. Don't want to see it. Don't talk to me.
It's Monday. I was up late last night. I'm about to fall asleep.
Oh,
I
yeah.
didn't like this, so. The answers you get to your questions may or may not be coherent. You don't know. It makes it more fun.
Take them.
Since yesterday. Since last week.
Control C is right there. So I didn't know that.
Oh.
Oh, I did a thing that pretty much confident. Yeah, and then you can try to hit Control Z to go back and then get Control X to come out.
How do you spell Justin? J-A-H-O-N. That's like freaking awesome.
Pretty rare car, so it could be the van. we don't usually go into model stuff like that. And that would be fun to try to find anything. I'm really sure that when we started, like that midnight, it's all the ground on the parking lot.
Alright, we're not done yet, but take a break, come back at 8:15, we'll go over the first part of this exercise, and then we'll move on to the second part. I mean, that depends a lot on the person.
So what you're saying is there's a maybe.
It's a bit of a personal question.
There's a bit of a maybe, depending on the developer, yes.
It's always like, let's say like entry class, and you'll keep it like synthesis of like drug addicts. So it's under buckets.
You wonder if we're teaching you to be drug addicts?
No.
I don't think we're teaching you to be a drug addict, no.
Like a drug addict.
I'm not sure that software is a one-to-one with drugs.
I mean, like, oh, it's so much fun. I don't know what I can do. Do you know what Kali Linux is?
Kali Linux?
So, like 4 years ago, I installed it on one of my computers. Coding out attack the ladder of my neighbor. It's just an FBI van. So I would attack it, and I would trigger it every 15 seconds. You find a list of like hard user passwords, like a log of like the most common ones. So you set it to run and you attack the guy's right. It'll take like 4 days.
That's a brute force attack, and they don't work very well.
So then that one didn't work. So there's one where you don't remember, like they have it like it's fixed now. You can't do it anymore. With the WPS, you know, the like 7 numbers. But I did that one and that one worked.
Why did you do this?
Well, I knew the guy. He was a programmer, so I was like, maybe FBI thing. But let's try and get into it. He was, no. Right.
Nice. It was a thrilling ride.
Yeah, it was 2 days of like.
That's crazy, man.
And this is like a couple days too long, like not doing more.
Doing that instead?
That's nothing compared to it. It's just like running a program.
Yeah, this is a different ball game, yeah. This is writing a program. It's not like writing a program. It is.
Long time to do them, it's been too long since the last time I ran this year, been working on. Yeah, yeah, that's pretty standard. You get 2, maybe 3 years without a problem.
Resolution view is great.
Maybe not understanding to
I saw something like PlayStation View, you might be having some troubles. I think it's pretty competition.
well, they
Keep raising the price.
did not come with a
View?
yeah, they've been slowly bit like that for sure.
So, my DirecTV bill went from 70 or 80 bucks to $200. Tried to do some negotiating and stuff, and it was pretty hard to do. So I got Sling TV, just like right when all those things started popping off. It was okay for $20 a month. Like 7 was what I really think I was paying. So I like that, but then you can only watch that on one TV at once. So you could every time that. So then I switched to View and watched it on like 3 or 4 different devices. Has good channels too. Like has local channels built in. I don't know, it's pretty cool. See, I think I started paying like $40 a month. Cool, I get everything I want. Pretty sure it's closer to $60 actually.
Just DirecTV now, and so there's 2 devices that can get it on. $25 a month is fine, and you can go to 60 pretty much the standard. Yeah, everybody does it.
That sounds about right.
They'll give you 100 channels, and you start getting that customer base.
I have a separate group for that.
Yeah, you can, it's like all the time now,
Yeah, that's why I got like DirecTV. I got it in the first place is so I could watch the whole thing.
Yeah.
You try to reference player in an array within
The course is what it takes.
yeah.
The game was on TV on Friday.
No, they
What do you mean?
Like, okay, so if can I
don't know what
reference the location that this object is in an array
Like
within
almost
the
many
object
hotspots
itself?
where there's
So it doesn't know about the array that's in it.
everybody.
Just knows that it exists.
There were like 3,000.
Yeah, you would have to find it in the array.
Oh my god.
So if you think about it,
You can't rent Eddie Johnson for it.
Now you could build an object that wraps an array, right? That you can add and push and pop from and whatever. That kind of could do that for you. Make it a smart array.
I was just trying to, because like, it tells us there that the players can create 3 unique 2 stars and subs. I was trying to like, when it prints the players, to tell them the first 2 are the starters, the last one is the sub.
Yeah.
But when I wrapped it in Procreate Hoops, I thought it would work, and it actually breaks the redundancy of entering all 3 players. It only like lets me enter one, and it will just quit automatically. So I was trying to figure out how I could do that without like without having starter repeated twice. I wanted starter and then print the first two in the array and then inject sub and print the third one. And I tried like messing with it.
Put them in an object. Objects in JavaScript are mapped, so they're more effective. So you could be like starter and then have an array of the starters and sub and then an array of the subs and print them in whatever order you want.
So I don't think they have like all the games have all everything. They'll have the white never ever. It's so fun. It's rare that I do that now. So I'm just
I want your team so you can sing.
I'm gonna go destroy this guy's name. Oh my god, the refs are so bad. They all know they suck. Before now, Alan is still doing the first fouls. I don't know how old this guy's been. Look at how Steve Albert was playing a couple years ago. He was starting to lose his shit. Out of the work. It was a crazy, I'm not a UFC guy, but it's like, you know what, I'm just so many crazy
Honestly, no, it gets really, really hot. It's an aluminum body. You better believe it. Why would you tell somebody that? That you're tired? Yes. Cocaine and meth? No thanks.
Maybe, you know that better energy drink? Like,
Could probably do it. I think I'll pass though.
And it's crazy, it's like driving out back.
Oh, it's only 35 minutes.
I missed 2005.
How old are you?
Oh, same 23.
You weren't even driving in 2005, were
No,
you?
my grandpa.
Okay.
I remember going and there was
Okay, 2013.
I remember the tour wasn't even the one I was south, it was just closed.
2013 is good.
Alright. Let's go ahead and talk about the first half of this assignment. So the first part was creating a player constructor that can take in information about the player, their name, position, their offensive and defensive stats, and then giving them some functions too, like if they played a good game, if they played a bad game, being able to print their stats, stuff like that. So you can define the function just like you would a regular function, right? Your constructor. Give it the properties you want to pass in. That part's nice and easy. Just passing them on in the function. Then from there, you can define the functions that you want to call in several ways. So this is the non-prototype version, right? So you can just attach them to this, which means this instance of the object will have these functions. So for good game, it flips a coin. If the value is equal to 0, then the offense goes up by 1. If the value is equal to 1, if the value is equal to 0, then it goes down. Oh no, it goes up. Otherwise, the defense goes up. Bad game, if the value is equal to 0, the offense goes down. Otherwise, the defense goes down. Right? So, just functions here. You can use your math floor with the math random times 2. And it'll either be 0 or 1. That's all you get. Those are your two options, right? So, again, 0, increment offense. 1, increment defense. Bad game is the opposite. We're going to go 0s to decrement, and 1's to decrement the defense. And then the print stats, very similar to what we did with that programmer, where we printed the info. Any questions on the functions?
Is there any way to like blow that up a little bit?
Sure, I can blow it up.
Thank you.
No problem. I'll slack this out too.
Okay.
So anyway, these are those base functions. Okay, so what else do we need to do? Well, we need to have a prompt to be able to create a new player. So first of all, we need to create starters, we need to create substitutes, and then we got to create a team, right? So there's a total of 5 players. I believe it's, what, 3 starters and 2 substitutes, or is it the other way around? I can't remember. But anyway, you want to create a certain number of them, right? So we're going to go ahead and go through our inquirer prompt. Now this is in its own function called create player. You ask for the name, position, the offense, the defense. In this example, they're actually taking the offense and defense and validating that they're numbers. If they're not numbers, inquirer can be like, hey, these aren't numbers. It sucks. I'm pretty sure, I haven't run this yet, we'll run this together, but I'm pretty sure it can keep you from entering those values, or it'll assign logical defaults. But anyway, you can validate them. And then when you're done, you go ahead and you get the answers out. You can create a new player based off of that. If your starter's length is less than 3, so if you don't have 3 starters yet, you go ahead and you push the player to the starters array. Otherwise, you and then you always push them to the team array because you want a full string of the team, but you also want the starters and the substitutes split up as well. So go ahead and push this to the starters array before we have 3 of them. Otherwise, we'll push them to the subs array because then they're a substitute. And we can go ahead and keep doing that 5 times, right? Because we need the 5 players, the 3 starters, and 2 subs. And then after we're done, we can go ahead and print the stats of all the players. So let me run it really quick. Ooh, caps. Team manager basic. Okay, player's name Carson, player's position. Just say forward. I don't know what game we're playing. Offense 10. Let's say if I put A in. So see if I put an A, something that's not a number for the defense, it actually deletes it. It doesn't even let me. So that's what you can do with the validate functions, which is pretty nice.
Wait, why one, I think?
Because there's these validate functions right here that basically check if it's a number. If it's not a number, it returns false. Alright, now I gotta take a number, buddy. Oh, it must be under 10, yeah. Alright. So. And then it'll print the whole team. Alright, I'm going to go ahead and slack this out, and then we'll start on part 2 of the exercise, which you may have already started out on. Let me go ahead and get this. Activities. Alright. So the next set of instructions are right here. You've already printed the stats, so once the code is functioning properly, we're going to go ahead and start playing the game. Okay, and there's some complex rules about what happens with this game. So this part's going to be pretty challenging. The important things that you want to get out of this exercise are how do constructors work, and how can we use recursive calls to call things multiple times with those asynchronous functions. Okay, so even if you don't finish it, that's okay. Go ahead and try it, but try to get those things out of it. So we'll give you 20 more minutes or so to work on that.
It was working good. And, I don't get it. So like I was doing it, and it works okay, like so far. So like I run the node around and it works. So like I'll just show you. Like I don't know why it does this, but so if I run it, it'll kind of work okay. But the thing that is weird is that if I say like that, if I just type in yes right there, it just like freaks out. It just like puts in a bunch of Y's for some reason. I don't know why it does that.
Whenever you do that in terminal?
Yeah, like if I type no, it does nothing. Maybe nothing. But I type yes, and then it's like freaking out.
Huh.
I thought it was my program.
I'm gonna try that. I'm gonna see if there's a bash command for yes that does something weird. Mine does that too.
That's so weird.
Yes is a command. Output a string repeatedly until killed.
Oh wow.
That is literally what the command does. Here's the man page for it. Written by David Mackenzie.
I feel like it's kind of a pointless thing.
Probably.
Do you have like code that you put in when you use something?
What?
Do you have code that you like when you're done making it?
Like code signing and stuff? No.
You don't have to worry.
I mean, if you commit it with Git, everyone can see who the committer's email and stuff was, so if I'm on GitHub and it's open source, they'll all know. Well, that's because that was a man page. It's different. It's like a readme. Here, this is a good one. I like this command. It's a train. Makes a train go by. It's cool. There's like a dash F, I think, that makes fire come out of the train. Oh no, that one's too small. Let's see. One of them will make him. There's a bunch of commands. There's like one to make fire come out and people go, ah, help, help, and stuff like that. Let's see.
What are you doing for that?
Oh. So.
Came here for this.
Here you go. Here's a flying one that has people yelling help on it. There you go. Anyway, that was the aside in terms of awesome command line programs.
Trains, the guy who's trains.
Well, we have a console lobby train
Whoa, you're hired.
Train.
Can't you just go to jogging and learn shit?
That's
It's a sick command.
You just build up off
For my second skill.
Did you know that?
It's not built in. I had to download it. I know, it's less fun then. No. Yeah, I don't know how you get it on Windows, but if you're on Linux, you just download the SL command. It's supposed to be like you do a typo for LS, and then you get a train instead.
That's a little
It
bit
runs
cool.
over your command. Yeah, let me show you the train command. You just do this. LS. What? Why do you think it's a regular?
Okay. Let's go over this one. This final part was really tough. Actually, there's a lot of functionality in here. As I was looking at it, it's actually not necessarily an easy one to do. This a tough one. Let me just install real quick. Alright. Oh, speaking of other cool commands, there's this one. Print a cow. That's cool, huh? Oh, right. I like that one. Anyway, so if we run this one, the team manager advanced, So this one's going to create our players. The example here is only going to create 3 players, 1 starter and 2 subs. It's going to then start playing the game, run through 5 rounds, where it calculates the total of your team's stats versus a random number. And if the random number is bigger than your offense, you don't win that round. And if the random number is, or if your offense is greater than the random number, you get a point. If the random number is greater than your defense, you lose a point. In between there, nothing happens. At the end of the 5 rounds, if you have a positive score, you win, and your team gets better. If you have a negative score, you lose, your team gets worse, and you can play again. So let's do Carson. I'll be forward because I don't know much about sports. I'm going to give me a 5 and a 5. This is going to be Tom. He will play backward. That's a sick position. He's going to be a little stronger, and this is going to be Frank, and he'll be center. And he's got a good defense. Alright, team offense 11, team defense 9. The random offense was 6, and the random defense was 11. So I won and I lost. So that sucks. So let's go ahead and make a substitution. I'm going to say no. I was scored upon. This time, the random offense was higher and the defense was higher. As you can see down here. Which is a real bummer. I'm gonna make a substitution. Who would I like to substitute? I'm gonna substitute in Frank. Okay, just 1. Who would you like to sub out? Or I'm gonna get rid of myself. We scored a point, but then we were scored upon. Okay. We'll run through a few more rounds. We lost. Our final score was -2. We really suck. Tom's offense has gone down. And Frank's defense has gone down. So anyway, our team sucks. The morale loss because of our huge defeat has caused my players to become worse, literally. So we're probably not going to play again. We've quit. Anyway, let's look at that code. Obviously, that's actually pretty complex what just happened there. This isn't really a trivial exercise at all. So if anyone finished, kudos to you, because this was a tough one. So we have our player. That logic hasn't changed from the last example. So right here we have slightly different code, okay? So we have our starters and our subs. We don't need them in the team form anymore because we don't care about that. We care about our starters. And then we can sub out our starters if we'd like with whoever's in our sub array. And you can make this bigger if you want. Change the number from 3 players to 10 or whatever if you really wanted to. Maybe generate random players for the user to make it more interesting if they want. So after you, the first thing it does is initializes the players, right? So let's go ahead and look at the initialize players routine. So here in initialize players, it's going to give us there's going to be 2 options. Basically, if we have less than 3 players, we're going to go ahead and go through that player creation. Now we've already seen this player creation. That was the same thing that was in the last example, where it loops through recursively and creates a new player every time. So let's take a look at that. So we go in here, it's going to create a new player, prompts for the name, position, the offense, and the defense, creates the new player, adds them to the array. If there's not 2 starters, it adds them as a starter. Otherwise, the 3rd player adds as a sub, and then it goes ahead and it runs at initialize players again. Now, slightly different, because the last example would have called prompt player creation again. But this time, they're calling initialize players. Why is that? Or initialize game, I'm sorry. That's because when you have the total number of players, you want to go into playing the game, right? So you could take this functionality that's in initialize players, where it starts creating the players right here. You could just call prompt player creation over and over again from prompt player creation until you get to 3 players and then call play game. But they put it in this function instead, so that you just call this function and it will know how to handle the next phase of the game after the players are created. Okay, so the functionality is getting pretty complicated now. You have to follow recursive calls, and then you got to follow subroutines that are going to call recursively back to the other routine. So we have 3 players. We've gone through this routine. We've created all of our people. Now we're ready to play the game. So first things first, we're going to increment to a new round. Remember, we're only playing 5 rounds. It'll tell us what round we're playing. And then it's going to pick the random numbers. So a random offensive and a random defensive number to compare against our team stats. And then it's going to go ahead and use our starters to calculate our team's offense and defense. And it's going to compare the two. So here it's just printing them so you can see them. It's going to go ahead and do a comparison. If our offense is greater than the defense, then we get a point. If our defense is less than their offense, then we lose a point, right? So here's where like the actual logic of the game, so to speak, comes into play. Now that we've been scored upon, this is where it gets really hairy and their example is actually really bad. There's some bad practices here. It's really hard to follow. So would you like to do a substitution? If you answer yes, so remember this is asynchronous, we're going into Inquirer. If you answer yes, then we're going to start another prompt inside of here. Who would you like to sub in? You pick someone, and then it's another then function inside of a then function. So we're getting into nested then functions. It's starting to get really hairy here. And it's going to go ahead and sub the players, right? So it's going to do an array substitution where it's going to basically take the substitute we want in the game. It's going to put them in the sideline, it looks like. And then, who would you like to sub out? It's going to do another then function. And it's going to take the person we want to sub out, replace them with the person we have on the sideline. And that other person that we're subbing out is now in the subs array. So some complicated logic here. The nested then functions, which is really nasty. There's a better way to handle this so you don't have it nested so deeply. But this one is a real tough one. And after that, we know we can play the game. And here's that else statement from way up above where we're like, hey, do you want to substitute? No. We're just going to go ahead and keep playing the game. Otherwise, we go through all of that crazy logic, 3 separate prompts, and end up right here where we'll, again, play the game. So we play the game. Where's play game? Play game. Play game. Okay, that was play round. We are going to play the game up here again. So if our round number is less than our max round, so 5, we can keep playing the rounds. Eventually, we're going to get to this end game call where it's going to be like, okay, if your score is greater than 0, then we're good. You won. We're going to call it a good game for everybody and basically make them better, right? Because they're going to get stat increases. Otherwise, we're going to call bad game if you lost and everyone starts to suck a little bit more. And if you happen to get a 0 score, flat out even, it was a tie, nothing bad happened, and then we can prompt, do you want to play again? Alright, that was a lot. Most definitely that was a lot. Why don't we walk through this together with debugging to see how it looks debugging. That way we can kind of follow what's going on. So we already know that basically the first real functionality is going to happen right here in the init players, right? Because the player constructor, it's just initializing stuff, getting it ready, and then init players is where we're going to get into the real functionality, the meat and potatoes, so to speak. So if I hit F5, let's see if the launcher picks up. I'm not doing anything in C#. Let's hit F5 again. Come on. Okay. Alright, so this is going to be kind of cramped on the screen because there's a lot going on. But we're at init players, right? That's where it's broken. If I hit F11, I can go in. So we'll see, we'll skip that. It'll console log init players. You can see it right down here. The starter's length right now is 0. The starter's array has nothing in it. The sub's length has nothing in it. So we're less than 3, right? When you add them together. Prompt player creation. So right here, because we're at this asynchronous function, there's a couple of things. One, we can't just step into this stuff. We got to set a breakpoint down here in the asynchronous function, or it's possible that while we're stepping over the breakpoint, it'll just skip it on accident. It happens. It's hard to debug asynchronous stuff. The other thing is, if we want to see how this validation logic works, we can set a breakpoint in there too. So I'm going to step in. You'll see I'll start going into Inquirer here. So this is actual Inquirer code. If you wanted to step through it, you could. I don't particularly care about that. So if I hit F5 to continue, it's going to, in the terminal, do nothing. Let's see. It is dead. It died. I don't know why it died. Huh. Alright. Let's try that again. So we already know past that phase. It is just getting here and then it is just dying. I don't even know. It's waiting for the input somewhere, but I don't know where it's waiting for it. So it's making it kind of tough to debug this. Interesting. Well, we learned a valuable lesson. Debugging Inquirer is effectively impossible. So that's nice. Very interesting. Okay, well, we're not going to be able to debug it, and that sucks. Because I really wanted to step through that. What's happening is it's waiting for the standard output. Well, it's waiting. It's written to standard output. It's waiting for standard input to get some feedback, but for some reason this debugger can't pick that up.
How often do you have to npm install? Or like every time you change something?
The first time you go in. First time you're working on that project. Let's see.
I didn't know if it was like the, official.
Nope. npm installs one time unless you change the packages. I might be able to go to the actual debugger. Let's check. I want to try to debug this with you guys. What is that port? Let's say on 25124. Hello. Yeah, it just kind of stopped. We'll have to figure out how to debug that. Well, that's a real bummer. Alright, we'll close the debugging menu. Anyway, as we would have seen had this debugging worked, eventually it would get here, and we'd be able to see it step through. We get to init players because starters was 0. So the length was -2, so the first player is going to be added to starters. And then we'll run back through init players. So go back to init players. See, at this point, starters will be 1, subs will be 0. We'll go through it again. We'll have another starter. Go through it again. We'll have our sub, right? And then we'll get to the play game. Are you guys following me at this point? Right? So now we're at the play game part. Because we have 1 sub and 2 starters. So when we come into play game... Ugh, this is a mess. Alright, we come into play game. Our round number is starting at 0. We set it up here to 0. We have max rounds of 5. 0 is less than 5, so we're going to go ahead and play a round. Let's see if F12 looks nice. Perfect. We come in here. Round is now 1. We console log that. We come up with our 2 random numbers for offense and defense. We calculate our 2 random numbers for the offense and the defense. Or we calculate our team's offense and defense. So we loop through our starters, right? Because they're the ones that matter. Then we can just console log them so you can see them. This is where we check. Is the offense greater than the random defense? If so, then we scored. Otherwise, if our defense is less than the random offense, we were scored on. And they both.
The dot forward times 20.
This one?
The random.
So math random returns a number between 0 and 0.999 infinity, right? And so it's timesing it by 20. So it's going to be between 0 and 19.999 whatever. Adds 1, so between 1 and 19 or 20 point whatever, and then does the math floor and reduces that to 1 to 20 because it takes away the decimal points. So the number is between 1 and 20. Alright, so we won, we lost, doesn't matter. Do we want to make a substitution? Yes or no? So how... Since the last activity is not critical, I wanted to show you how we can make this a little bit better. So when you have nested thens, these are called promises, which we're not quite at yet, but I'm going to bring it up now because this is really bad practice, and when you do it, it's super hard to follow. Promises can form a chain of then functions, and you can make them linear, basically, so you don't have to have these nested deep then functions. And you can do that by returning a promise. And assuming these are true promises coming out of Inquirer, it will work. And it looks like they are. So right here, if the answer is true, we want to continue. What we can do is return inquirer.prompt, and then we have this then. And if I can find the end of the then and not blow something up. So right here, we can call .then again. Actually, I should be able to just paste what I took. So now we have our sub in right here. And for this one, we can again return inquirer prompt, because when we get these promises, they're literally just an object that we can effectively return from a function, right? So at this point too, we have another .then. And now we have it nested to the point where it's only one deep the whole way. This one poses a little bit of a problem because play game right here doesn't return a promise. So sub in would be undefined when it came in, because the promise is going to return something either way. So this one gets kind of confusing no matter how you slice it, which is really kind of a bummer. And there's more ways you can change it up. But when we go through the inquirer process, it's going to give us some subs. When we call the play game, we're going to get nothing here. And so the way we can circumvent this is if not sub in, we can return again. And for here, if sub out, we can also return. And theoretically, have I not destroyed something, this will still work. And it looks like it's still working. Would you like to do substitution? Yes. Who would I like to substitute? Test. I'll substitute them for Carson. Oh, there you go. Now I got an explosion. So there's more refactoring that has to be done here to really do it, but the point is that when we get to these nested thens, you don't really want to do that. You want to find a better way to just do it in a linear chain. This is called a promise chain versus nested promises. Yeah, that's a good idea. So I'm going to create an index.js, and I'm going to create a promise chain for you that makes a little bit more sense. So don't worry about this. Imagine this is what inquirer prompt is doing. So I can call inquirer prompt, right? And then I can do .then. And in here I can do stuff, right? And then I can actually, like, say I wanted to return a number. The way Inquirer was doing it was they would do something like a new promise. I gotta make another function. they would do something like this, where they would say call next function. Let's just say it takes in 10. Dot then. And this one doesn't return anything, right? And then they could even call a last function. And they would do something like this. So this is kind of what the inquirer one looked like. If I node this, I'll get Carson 10, this is the end, and then true. And so if we look at that code again, notice it's kind of dense. You'll see the inquirer prompt is going to do this. It's going to return an object with the name Carson, and I'm going to console log it. Then this next function is going to console log a value, and then inside of that promise's then function, it's going to then call another function, last function, which console logs this as the end and returns true. And then the function after that is just going to console log the result of the last function, which is true. So how do we clean that up? Like I was just saying, we could instead return here now we have left with this, which does the effectively the same thing. It's just much cleaner. So that's what I was trying to get at, is you want to chain your promises in this kind of like very linear fashion as opposed to nesting them within each other, which is a very dense subject that I probably shouldn't have broached looking back at the last 10 minutes of this class. But either way, this is just my little tidbit. Anyway, I'm going to go ahead and slack out the solution, or Stephanie, Chris, one of you could stack out the solution to that last exercise. We'll worry more about promises later because we are going to get into them more. Just note that that example is really hard to read, and I understand that, and I think it's because it's bad practice. It's bad semantic JavaScript. Okay, so now that I just confused everyone, Fist 5, how are we feeling on this node stuff? The node, the activity we were doing, not what I just said. Just the recursive functions and stuff like that. Feeling better about that? Okay, feeling okay about that. Okay, great. Okay, so what else can we do with constructors? Really quick, we'll do one more exercise. Can we call constructors within constructors? So say we have this cast member class, right? It defines a nice cast member constructor that we're then exporting with our module exports. Everyone remember the module exports? Fist 5 on those. Where you just assign something to module exports and then you can import it from another file. Okay, I got mixed results on that one. So from our movie.js file, you can see we have this require cast member. Here's the cast member JS file, and we're doing module exports. We're exporting the constructor right here, okay? And right here we're importing the constructor. And down here we're using that constructor. So what is the point of this exercise? Well, can you use constructors within constructors? I know that's small. I won't leave it like that forever. And the answer is yes, you can. They're effectively glorified functions, right? So you can use them in any function. There's no limitation on how you use them. They return an object is what they do. That's the return value. But they're just functions at the end of the day. So totally, you can use them wherever. Wherever you could use a regular function. And so right here, add cast member actually takes in the gender, name, and role, the things that are important to define a cast member over here in this constructor, and it creates a new one with the constructor that it imported and pushes it to the cast array. Now if I go and look at the main.js file, so the file that actually has the bulk of the logic, now we're importing from the movie.js, okay? And right here, where module exports, we're exporting this movie constructor. We can create a new movie, and then every time we want to add something to the cast, we can call this add cast member function, which takes in those parameters and creates a new cast member and stores in that array, right? So if we can actually walk through this one. This one we'll be able to debug, thankfully. And we can actually see how these constructors work. I'm going to pull this over here. Alright. So first things first, we're going to construct this movie, The Matrix, right? So now we're in this movie constructor that we imported from the movie.js file. We have our movie name, The Matrix, our genre, action sci-fi, and our budget, 63 million. We're initializing our cast. We're setting our movie name equal to movie name, so now it's The Matrix, our genre, and our budget. And then we're creating this add cast member function, which you'll note is skipped by the breakpoint. It isn't called yet. If we keep going, we'll console log. And if I open up my debug console, you'll see this stuff being console logged. And you'll notice there's no one in the cast yet. As a matter of fact, if I look, it's just an empty array. So now we want to add a cast member. What's going to happen? We're going to go into this function. Now we're going to add a new cast member. So we have our gender, female, name, Carrie Ann Moss, and our role, Trinity, right? We're going to go into the new cast member constructor that we defined in this cast member.js, right? We're going to assign this stuff. We're going to create some functions. And boom, we have a new cast member in the cast array. You can see in this array, it even says cast member, gender female, and shows all of their stuff, right? Carrie Ann Moss, Trinity. So we can keep going. Now, if we print the cast, you're going to see it prints the cast member. So let's add another cast member. Now we're inside the constructor here. We add the cast member. We'll add a few of them. So I don't care about breaking in this constructor anymore. We've seen it enough. If we look at our cast, we now have 3 members in there. Add another cast member. Print here. And we have all of the members of our cast. Now we can go ahead and read through all of their profiles, right? So now we're going to read the profile of this person. This is a female, this is an actress, and her name is Carrie Ann Moss. She's an actress who plays Trinity, right? It's going to console log that out right here. Boom. We're going to do it again. That one's Keanu Reeves. That one's Lawrence Fishburne. That one's Gloria Foster. And then Hugo Weaving. Was it helpful stepping through the program, kind of see how it executes the code? Did that actually help, or did it make it more confusing? I see some nods that it was helpful. 50-50. It's kind of hard to follow because you're jumping across files, but that is exactly what's happening in our code. So the point is, there's no stipulation on how you use constructors necessarily, inside other functions, whatever. They're just functions. Alright, how are we feeling on constructors? Feeling okay on them now? Do we feel better than we did on Saturday? That's the important question. Yeah, we feel better? I don't think constructors today were the hard part of today's class. I'm going to say that exercise was probably the hard part, and none of that was necessarily new, it was just a lot, right? Yeah. So, Any questions on anything we've gone over so far? So there's technically one more activity. It's not marked as critical or anything. It takes 15 minutes. If you want to do it, I can give it to you, or we could just say class went till 9:30, call it a day. I'll let you guys decide. I have to stay till 10, so if you want to stay and do the activity, by all means. Otherwise, just go home. No, I have to stay till 10. So if you want to stay, you can stay and do the activity. If you want to leave, by all means, leave. I'll give you the activity, but I'm going to call it class. I'm going to end the stream. That was the important stuff for today, so... Alright, I'm going to end the stream, and we'll slack out the next